cause in which a net external force for there to be any change in velocity, either a change in magnitude or direction. An object sliding across a table or floor slows down due to the net force of friction acting on the object, which basically means an object at rest will stay at rest, and an object in motion will stay in motion unless a force acts upon it. In this experiment, we got an index card, a coin, and a cup. The coin stays on the index card because the force applied to the index card wasn't greater than the frictional force. The coin stayed in one place because the force applied to the index card was great enough to counteract the frictional force. Once the card was gone, gravity pulled the coin to the bottom of the glass. Newton's second law states that the time rate of change of the momentum of a body is equal to both the magnitude and direction to the force imposed on it, which basically means the greater the mass of the object being accelerated, the greater the amount of force that is needed to accelerate the object. In this experiment, we used a chair and a person to represent how the mass of an object is changed and how much force is needed to accelerate it. As you can see, the chair was pulled with ease because there wasn't much gravity pulling on it and there was less frictional force, so it weighed less. When we pulled the chair the second time, there was more gravity on the chair, which made it weigh more and added more frictional force.
Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. This is an example of Newton's third law because when you jump, your legs apply a force to the ground, and the ground applies an equal and opposite reaction force that propels you into the air. This is also an example of Newton's third law because it ensures that the ground will push forwards on you, accelerating you as you're starting off, and then countering the force of air resistance. The air resistance force is also mediated by Newton's third law. As you're pushing forwards on the air is pushing backwards on you. The action-reaction pairs are the same thing as each other. With your foot stationary on the ground, your muscles are pushing your foot backwards away from you, and then your muscles are pushing your body forwards away from your foot. These forces are contact forces. Where gravity is concerned, with action at a distance, it's more obvious that the reaction-action pair are separate.